Welcome to class, everybody. Today the question we're going to answer is, do all liquids boil at the same temperature? And if so, why? And if not, why not? Okay? Now, in order to do that, we're going to heat some liquids from room temperature to boiling. The liquids we're going to be testing today are distilled water, distilled white vinegar, 91% isopropanol, 70% isopropanol, and witch hazel. Okay? We're going to work together in groups again. We're going to need four groups of four. So this table and that table together and throughout the rest of the room. We're going to need a manager, a recorder, a collaborator, and then a presenter, because after you've gotten the information together in your groups, we're going to join together again as a class and come up with a uniform set of rules for the experiment today. The first question we're going to need to answer is, what lab supplies do we need in order to generate a heating curve, or in order to heat a liquid from to boiling point? Okay, and there's a list of lab supplies on your table. Go ahead and select those. The supplies that you'll need for that. The second question that we're going to answer is, being as specific as possible, what will we need to keep constant for each trial to make sure that the only thing we're measuring is the boiling point of the different liquids? And these are all listed on the board up here for you as well. Okay. The third thing, safety. What safety rules will we need to follow? We've all worked in the lab before. We know what we typically do. So think of lab safety rules that are applicable to this type of experiment. Okay, the fourth thing that we're going to be working on is, how do we present our data? How do we collect it, and how do we present it to the rest of the class? Okay, we're going to start with 5 minutes, see if that's enough for us. And then we may need to stretch it out to 10 minutes, because those are four big questions. Okay, everybody get in your groups, and let's go ahead. Okay, everybody, here's the setup we came up with as a class. Our heat source is just a regular electric range, and we decided that in order to make sure that the heat input into each sample is uniform, on setting 9. Each of our liquids in just a regular metal saucepan on the stove, and in order to measure out 500 mils of each sample, because to keep the volume consistent, we're just going to use this liquid measuring cup. Now, the cool part here is that we, rather than a thermometer, and rather than keeping track of our data manually, we have a data probe. This will sit inside the liquid as we take the sample. Automatically, over here, here's the big thermometer. Finger tells us our temperature reading here. It lists our data. It's going to collect it all right here in this table. Then over here in the graph, it's going to generate the data. Watch that in real time. Now, last but not least, we have our safety equipment. Before we get started, we have our safety glasses on, just like we decided. Hot pads. We need to handle the labware, and then we're going to make sure that we keep the handle of the pan over the stove so that no one gets hurt or spilled, and then of course no horseplay in the lab. Okay, here's our setup. We've added the water. It's at room temperature. Now we're going to move it onto the hot plate and then turn it on. So we're going to turn this to 9. Okay, now we're going to come back over here. We're going to click on the collect button. It's going to start collecting a reading every 1/10 of a second, so it's quite a few for us. As you can see, here's the data generation. Now this is water, Bobby. What do you think water is going to boil at? 212 degrees? What scale is that, Melissa? Fahrenheit. Good. What are we reading in? Celsius. Good. Okay. So that's a little different than the Fahrenheit scale. What temperature does water boil in the Fahrenheit scale? 100 degrees. Okay. So what we can do, what's kind of cool, is we can stretch our graph down so we can see all the way up to 100 degrees. And we're going to click on Predict here. And we're going to draw a little circle up here. That's not a very good circle, is it? Well, we're predicting that it's going to get up here somewhere into the 100 degrees. But that's our prediction. Okay. Well, let's now what's happening with our temperature? We see that it's going, it's raising. Okay, so we're putting heat in there. What's happening to the molecules of water? Mike? Good. Okay. They're moving faster. The energy's going in. Okay. Okay. As we can see, the graph is starting to flatten out. And if we look over at our sample here, we also see that it's starting to boil. So, what's happening at this point here, we see that the temperature has stopped increasing, but we're still putting heat in there. Where's the heat going? What's it doing? Julie? Right. All that energy is going into that sample to change it from a liquid to a gas. Great. Okay. Now we've generated heating curves for all 5 of our liquids. We have water, we have vinegar, we have the isopropanol at 91%, the isopropanol at 70%, and then this curve in here is our witch hazel. So from this, do all liquids boil at the same temperature? Bobby, what do you think? No, you're right, they don't. Now, as a group, what I'd like you to do is get together again and answer the questions to the lab write-up, such as what did you observe when you generated your heating curve? How do the heating curves differ from each other? And what is happening at the different points in the curve, specifically to the energy? And then why are our boiling points different than what the experimental errors are, or what the experimental values are? Okay. All right. And then remember to have a reporter, and we'll talk about it as a class. Okay, I think all of our presentations were great. Everybody really seemed to understand heating curves. Now, how does the fact that liquids boil at different temperatures affect our everyday lives? Nobody? Okay, how many of you drove to school today in a car or on a bus? Yeah, most of you? Okay. How many of you enjoyed the heat from your furnace this morning? Yeah, just about as many. Okay, and how many took a hot shower this morning or last night? Okay, every one of those benefits is because liquids boil at different temperatures. When crude oil is pumped out of the ground, it's a mixture of a bunch of different liquids, and we're able to separate those out and make them useful into such things as natural gas, gasoline, heating oil, kerosene, all those things. Now, the last thing I wanted to show you was a YouTube video on how that actually takes place. So before the bell rings, it's just short. Let's watch that together. Thanks for all your help today.